their site, log in there, and ask for a specific server of this configuration. Now what they do is they create a virtual environment which will give me the performance of the server which I have requested. It's not physically there, but there are so many machines on the AWS platform which are being used. So what it does is it consolidates all these resources and all these processors power to give you the processing capacity of the machine which you have asked for. So from our point of view, we feel that we have got that server. But technically what is happening is it might be you getting the performance by using so many machines. Now that we need not be aware. That is transparent to us. Then another example I can give is you want Visual Studio, which is a software for development. Now, just for developing one application, if you're going to buy that, what you call Visual Studio software, it's going to be very expensive. So you don't know whether you'll get a project in future on Visual Studio itself. So instead of buying, what I do is I can log in to the, say for example, AWS service, log in there, get connected, request for this software. One software or more than one software also I can request. So I can just put a tick. Literally, it's like as easy as putting a tick there. Now, once I put a tick, I need to make the necessary payment, initial payment, and then the software is available to me via the net itself. I can use it. Once it is over, I can disconnect myself. The biggest advantage here is I am paying for that software only as far as I am using it. If I am using it for 1 hour, a very nominal amount will be charged for me for that 1 hour. Use it for 10 hours, a nominal amount will be charged for 10 hours. So what is my saving on that? My saving is 1, I don't have to buy that software. 2, tomorrow that software might get outdated and a newer version might come. Now, if I'm going to buy the old software, I might have to buy the new software or upgradation cost I have to bear. Whereas on the virtual platform, I can take that new version available to me at the same cost probably, as long as I'm using it. So this is something like hardware on rent or software on rent. Virtualization is done based very similar to that. So server consolidation is consolidating an environment and creating a server for you, right? Then disaster recovery. Now, when you have a virtual server, you can also have another virtual server, maintain a copy of the data so that even if one virtual server crashes, or in some cases what happens is I have a server in my office, plus I create a virtual server and transfer all the data of my server to this virtual server. So instead of maintaining 2 physical servers, what I do is I maintain 1 physical server and 1 virtual server and upload the data on my server to that virtual server. So even if my physical server fails, I have a virtual server from which I can re-download the data and start using my system. Or sometimes even without downloading the data, I can use the virtual server as my primary server and then continue working, thereby avoiding disaster effects. Testing and training. Virtual environment is the best for testing and training. You might have heard about flight simulators. These are all virtual environments. What is the advantage of using simulators for teaching driving? Physical accidents are not caused. By the time you start driving a car, you might have undergone all possible situations of a traffic environment on a virtual environment. So for testing also, if you want to test a particular product, it is better to test it virtually than physically. Then portable applications, developing portable applications. If you have various virtual servers, you can actually test your product on all these things. Now, as far as a website is concerned, for example, the biggest challenge faced by website developers is that they have to test their website on various browsers. Now, if I use Chrome to develop my website, it will work fine in Chrome, but that doesn't mean it will work fine in Explorer also, or Firefox also, or Safari also. I need to test it in each and every platform. Of course, if I have a Windows machine, I can have Firefox, I can have Netscape Navigator, I can have Explorer, I can have Chrome, I can test it all. Now, what if I want to test on a Linux machine and Chrome under a Linux machine? Now I'll have to set up a Linux server, which is always not feasible. So there again, I can go online and get a Linux machine on rent kind of thing online. I can upload my site into that server and then run it and execute it and see whether it's working properly. Then I want to test it on Safari, right? So again, I can go online, get an Apple machine on rent virtually, and then run my website on that and make sure that it's working properly. So thereby, it helps me to develop portable applications without incurring a lot of. Then comes portable space. Literally, whatever you store on virtual machine is stored on the cloud, which you can access from anywhere. So that is why we call it portable workspace, accessible from anywhere. So for virtualization is used for server consolidation, disaster recovery, testing and training, portable applications, portable workspace. Now, common types of virtualization. One is hardware virtualization, network virtualization, storage virtualization. Now, I know you might be finding it slightly difficult to understand the concept, but soon we are coming to certain slides which will actually give you a better idea about all this. Hardware virtualization means you are virtualizing a hardware platform. You are virtualizing a server. You are virtualizing a client, right? You are virtualizing a data farm, whatever it is, on the cloud. Network virtualization is you can create a network on the internet, on the cloud, wherever it is, for testing your applications or even connecting your virtual machines with one another. Storage virtualization. I'll give you a simple example. Suppose I have a 500 TB, remember, terabytes of data with me. I don't have a hard disk of that capacity. And getting a 500 TB hard disk is going to be pretty expensive. So where do I store my data and how do I store my data? Again, virtualization comes to my help. Now, when I virtualize, what happens is I can actually create a storage space of any quantity that I want on the virtual arena. Now, what happens there is the virtual platform which provides me with this facility, what it will do is it will collect all the space available to all the machines connected in that particular environment and create a module of 500 data and then give it to me. Here, remember, I feel that it is being stored on a hard disk which contains 500 terabyte space. But what is actually happening is my data is stored on different hard disks spread on different machines, not on one single machine. It is spread on different machines wherever space is available and then put across. Now, something like isolation camps, quarantine camps, which are happening now. Government has created quarantine camps. How? They don't have so much of space to put everything in one location. So what have they done? They have taken hostels and common stay areas from various locations and then made them ready for this. So from the airport or railway station, when people come in, they are moved to the respective locations depending on space availability. But imagine from somebody coming from outside. They are saying that 1 lakh of people or 2 lakhs of people are going to come down. And Kerala is prepared for that. We have that much of space. When you say, if you look around, are you going to find one location where you're going to have, where you can house these 2 lakh people? No. This 2 lakh is spread across various locations. But we don't have to be bothered about that. What we have to be bothered is whether I am getting a bed in the quarantine, this thing or not. Same here. So when I store this huge file, it is not going to be stored in one place. It is going to be stored on different machines, different hard disks, etc. But for me as a user, I need not be bothered about this. So that storage is virtualized for me. Virtual. It is not physically there. It is virtual. I feel that it is there. So that is areas where virtualization is used: hardware, network, and storage. Then comes grid computing. Now, this is a computer network in which each computer's resources are shared with every other computer in the system. It is a distributed architecture of large number of computers connected to solve a complex problem. In the grid computing model, servers or personal computers run independent tasks and are loosely linked by the internet or low-speed networks. Now, what is this? Now, let us go back. Say, for example, most of you are doing articleships. You will have machines in your office, 10 or 5 or 10 of them. Now, at a given point of time, how many machines are actually working? Maybe 3 or 4 remaining are idle. Or the type of work that is done on those machines are not so much resource consuming. Simple works. That means at a given point of time, only 4 machines are utilized completely. The remaining 6 machines are not utilized completely. They're having free storage, they're having free processor time, etc. So people, when they found this, that in an environment at a given point of time, you're having a lot of resources that are being unused. When people came across this concept, what they did was, they started thinking, why not connect all these machines together and then share the workload between these machines? Now remember, this is not a network. This is combining machines to form an interconnected platform where resources can be shared, including processing, memory, hard disk storage, etc., etc. This is called grid computing. Right? Now, here in the diagram, you can see you have a control server which controls the grid. Tasks are there. Tasks are shared between the different grid nodes. And what is a grid node? Any machine connected to the grid is called a grid node, a terminal, what you call. So by doing this, what the advantage is, if there is some heavy task on one of these machines, that task can be distributed. The load can be distributed between different subnodes, thereby getting the work done faster. So as per definition, this is a computer network in which each computer's resources are shared with every other computer in the system. It is a distributed architecture of large number of computers connected to solve a complex problem. In grid computing models, servers or personal computers can run independent tasks and are loosely linked by internet or low-speed network. The whole advantage of grid computing is it is cost-effective, cost-efficient. Using a network like internet, you can connect all these machines with one another and then balance the workload between these machines, thereby getting a more efficient platform. Now, what are the benefits of grid computing? As I told you, there are a lot of underutilized resources. If you use grid computing, you can make better use of underutilized resources. Then resource balancing, as I told you, the memory can be used, hard disk storage can be used, the processor speed can be used. So a balance can be created between various machines in a network. Parallel CPU capacity. If there are tasks which can be done parallelly, you can share it between the different machines in the network. You can use a machine which is free to handle a complex task and even distribute the task among different machines if more machines are available to you, thereby parallelly getting the CPUs to work on a particular task. Then virtual resources and virtual organizations for collaborations. If you can connect it between your branches, etc., it becomes a collaboration platform. very effectively and efficiently working collaborative platform. Then, sitting on my machine, I can access additional resources. Say, for example, internet connection, which is being shared by everybody, can be accessed. I can probably get access to a camera placed somewhere else. I can get access to a scanner placed somewhere else. I can share my printer. All these things are possible. Reliability is high because it's a small network, all interconnected. It's under your control, so reliability is very high. Management is also simple because it is always small. So advantages of grid compute. Now, grid computing, please remember, even if you don't have too much of technical knowledge, please remember it is interconnecting machines together to help us to share resources. Right? Because as I told you, not all machines will be used all the time. So in some cases where the workload is increasing, if you have free machines, you will be able to share the work between those free machines. That is a big advantage. So making use of underutilized resources, resource balancing, parallel CPU capacity, virtual resources and virtual organizations for collaborations, access to additional resources, reliability, and then finally management. Now, types of resources. A grid is a collection of machines sometimes referred to as nodes. So any machine which is connected to a grid is called a node. Even a machine which is connected to a network is also called a node. It has got resources, it has got members, donors, client, hosts. All these names can be interchangeably used. So either you can call it a node or you can call it a resource if it is available,